Hello everyone, welcome back to another video. This is a dilogarithm based integration question which is I equals to 0 to pi by 2 ln sin x tan x sin x dx. Go ahead and try some of you if you can, or others you can just watch the video. First, let's separate these two guys. We know that tangent of x equals to sin x over cosine x. So we will get sin x over cosine x dot, there's a sine part there, so we can write this as sine square x. We know that sine square x equals to 1 minus cosine square x, so we can just plug those things there. By giving this cosine separately, we are finally left with 1 over cosine x is actually secant x minus cosine of x. Now we are ready to plug this thing into that above integration and we'll finally get this 0 to pi by 2 ln sin x dot secant x dx minus integral 0 to pi by 2, let me write that down, minus 0 to pi by 2 ln sin x dot cosine x dx. Okay, cool. Now we have something like this. Let's name this one as I1 and this part as I2. Let's try to solve the I2 part first, which is look easier. So I2 is actually 0 to pi by 2 ln sin x d sin x. Now we have the question like this. We need to read like this. We need to integrate ln sin x from 0 to pi by 2 with respect to sin x. So when we do some integration by parts here, we'll get sin x ln sin x 0 to pi by 2 minus 0 to pi by 2. What we have here is sin x dot 1 over sin x d sin x. And this sin x and this sin x will cancel each other out when we are left with d sin x only, which is, let's plug this value in and we'll get completely 0 here. So we are left with minus sin x from 0 to pi by 2, which is equals to minus 1 only. So we finally found the answer for the I2 part. If you are not familiar with this integration, this type of integration, you can go ahead and try this one first. Ln x dx. You can see the similarity between these two guys. We have sin x where we have x in here. So for this part, we'll get the answer x ln x minus x. Don't forget the c. Actually, I did the same thing here. Okay, now we'll move on to the I1 part. I1 we have 0 to pi by 2 ln sin x secant x dx. Integration of secant x dx is actually ln secant x plus tangent of x. Okay, so we can now rearrange this like 1 plus sin x over cosine of x. Okay, now we can do some integration by parts for this question. So it will become ln 1 plus sin x over cosine x dot ln sin x from 0 to pi by 2 minus 0 to pi by 2. Well, now what we have here, we need to put this part same back here again, and we have to differentiate ln sin x and put it back there. So this part actually becomes here, and when we differentiate ln sin x, we'll get cosine x over sine x dx. Okay, cool. So we know that this part actually becomes 0. So we are left with minus parenthesis. Let's separate these two guys. So we'll get ln 1 plus sine x cosine x over sine x dx minus 0 to pi by 2 ln cos x dx over sine x. Okay, don't forget the bracket here. Now, we should know that dilogarithm function, that if I differentiate both sides of dilogarithm of minus sine x, we'll get minus ln 1 plus sine x over sine x dot cosine x. You can see this part actually here. So we are left with equal to, well, there is a minus part also there, so you don't have to worry. So we can just put dilogarithm of minus sine x from 0 to pi by 2. And we have another part there, plus the other part of integration. We can put that as I3. So this actually becomes, what is Li2 of minus 1 plus I3? Well, Li2 minus 1 is equals to sigma n from 1 to infinite minus 1 to the power n square, which is minus pi square over 12. You guys should know that. So we can finally say that minus pi square over 12, terribly sorry about that, plus I3. Now we have to solve the I3 part. I3 is equals to 0 to pi by 2 ln cos x over sin x dx. Well, now I'm going to do one trick here. I can write this as 1 over 2 0 to pi by 2 ln 1 minus sin square x over sin x cosine x dx. Well, 1 minus sin square is actually cosine square x. So in the logarithm part, using the power rule, we can get the 2 outside the function, and the 2 and this 2 will cancel each other out. So you can see that these both are the same. Now let's look on to that d over dx li2 sine square x. We'll have minus ln 1 minus sine square x and sine square over x. If we differentiate sine square x, we'll get 2 sine x cosine x. So we'll get this part, this one, and cancel each other out, and we are finally left with minus ln 1 minus sine square x, we don't forget the 2 there, and cos x over sine x here. So we can finally put, you can see that's an extra additional 2 there, so minus 1 over 4 dilogarithm of sine square x 0 to pi by 2. So now if we plug those values there, we'll get Li2 sine pi by 2 is actually 1, and we know that Li2 of 1 is sigma n from 1 to infinite 1 over n square, which is, we usually say this as zeta of 2, so which is, we get pi square over 6. So we are finally left with the answer for I3 is minus pi square over 24. Right. Let me erase this and write okay. Minus pi square over 24. Well, now it's time for us to get everything done. So our first equation I equals to, we did separate these things as I1 plus I2. Then I1, we did put something like this now. Eraser, okay. We did minus pi square over 12 plus I3, and for I2 we simply just got I1. So for I3 we got minus pi square over 24. I mean, terribly sorry about that. We need put okay. So I think we finally have the answer, minus 1. So final answer we have here is, I think something is wrong. It should be minus there. Terribly sorry about that. So minus into minus will get plus 1. So we have final answer minus pi square over 8. That is the answer. Okay everyone, that's it for tonight. Like my video and please subscribe. Thank you.